Now let's discuss the functional groups. According to this website, functional groups are substituent atoms or groups of atoms that are attached to specific molecules. Now remember that functional groups are organic compounds. That's why they are being studied in organic chemistry. And they are organic compounds because they are commonly made up of carbons. We will start with the first functional groups, the alkanes. They are made up of hydrocarbons, that means a combination of carbon and hydrogen. Alkanes has a wide variety of uses, but most importantly, they are raw materials in making gasolines and lubricating oils. So commonly, alkanes are gases. Let's have this example, CH4. Let's draw the structure of CH4, which is this. As you can see, this compound is a covalent bond. They are sharing their electrons, and you know that the maximum electrons of hydrogen is only 2. So this hydrogen has only 2 electrons. That means it is already enough for this hydrogen. And same goes with the other 3 hydrogen. They only have 2 electrons each. And since this is a covalent bond, if you're going to focus with carbon, all the electrons of this 4 hydrogen are also electrons of carbon. Therefore, carbon has already 8 electrons, following the octet rule. The name of this first alkene is methane. Always remember when it comes to alkane, they are single bond and they are using the suffix "ane" in their name. So when it comes to alkane, there is no double bond or triple bond and other functional groups involved. Remember, when it comes to alkanes, they are all single bond. Let's proceed with the second alkane, which has 2 carbon and 6 hydrogen. So if we're going to write or to draw its expanded form, it should be like this. There are 2 carbon and there are 6 hydrogen, 3 each carbon. So if we're going to write its condensed form, it should be CH3 from C1 and another CH3 from C2, since they have 3 hydrogens each. If you want to check if they following the octet rule, you may do so like that. Count the number of electrons of carbon 1, there are 8. Same with carbon 2. Now with regards to the name of the alkane that has 2 carbon, it's ethane. We can proceed with the next alkane that has 3 carbon and 8 hydrogen, and then you may count the number of electrons so that you may know if they are following the octet rule. So in this case, we have 8 hydrogen. If we're going to write its condensed form, it should be CH3, CH2, CH3. Because C1 has 3 hydrogen, C2 has 2, and C3 has 3. So the name of this alkane that has 3 carbon is propane. Starting with propane, no, actually starting with ethane, we can have the line structure, but the line structure for propane is like this. Each dot is the number of carbon. In this case, we have 3 carbon, so it is propane. Next, let's proceed with the next alkane that has 4 carbon and 10 hydrogen. If we're going to draw its expanded form, it should be like that. And its condensed form, it should be like this: CH3, CH2, CH3. Having C1 has 3 hydrogen, C2 and 3 has 2 hydrogen each, while C4 has 3 hydrogen. Starting with this alkane that has 4 carbon, you may use shortcut for condensed structure. Just write the CH3 and then count the number of CH2. In this case, there are 2 CH2, so you may write it like that. I guess the name of this alkane is very known to you, which you are using here. Yes, the name of this alkane, which is a gas, is butane, which has 4 carbon. If you're going to draw its line structure, it should be like this, wherein it has 4 points pertaining to 4 carbons. Now let's proceed with the next alkane, which has 5 carbons and 12 hydrogens. If you're going to draw its expanded form, it should be like this. There are 5 carbons with 12 hydrogen. And then if you're going to draw its or write its condensed structure, it should be like that. And that is the shortcut of its condensed structure. You can use this shortcut of condensed structure provided there are no attachment, because in naming this you will encounter attachments. But as of the moment in time, I will introduce you first to the 10 alkanes. Then the name of this alkane that has 5 carbons is pentane. Starting with pentane, alkanes are not very difficult to remember because you just need to remember shapes. Pentagon has 5 sides. So do pentane has 5 carbons. So if you're going to draw its line structure, it should be like that. There are 5 points pertaining to 5 carbons. We may now proceed with the next alkane, which has 6 carbons. So there are 6 and then just write the hydrogen. There are 14 for its expanded form. For its condensed form, it should be like that. Or you may use this shortcut. And then the name of this is hexane. Remember, the shape of hexagon has 6 sides, so do hexane has 6 carbons. So its line structure should have 6 points. Next, let's proceed with the next alkane that has 7 carbons and 16 hydrogen. So if we're going to draw its expanded form, it should be like that. There are 7 carbons and 16 hydrogens, and its condensed form should be like that, or you may use the shortcut CH3, CH2, 5, and CH3. Since there are 7 carbons here, I guess you may guess the name from the shape of heptagon, which has 7 sides. Then the name of this alkane is heptane, and its line structure should have 7 points, like that. For the remaining 3 alkanes, I want you to write their expanded form and condensed form, same with their line structure. I guess you can do it with your own.